Welcome to our presentation describing the metrics we use in NeuroLynQ. This is Jeff Gill presenting. This is our third in a series of mini presentations. In the first, we discussed the importance of System 1, or non-conscious processing, to market researchers. The second presentation discussed using biometrics to measure System 1 activity. In this presentation, we will explain how NeuroLynQ metrics are calculated so you will know exactly what we are measuring with NeuroLynQ. The next mini presentation will discuss the reliability of the NeuroLynQ metrics, and the final presentation discusses why Shimmer believes that biometrics will become the dominant neuromarketing technology. NeuroLynQ metrics are actually quite simple, but they are surprisingly powerful. At the top level, our focus is on understanding the extent to which people are having a non-conscious, you might almost say visceral, response. We start by classifying each individual into one of three states: not responding, having a medium response, or having a high response. To get an aggregate measure of the audience, we just look at the percentage of the audience in each category. We go through this process every 0.4 seconds to get a moment-by-moment view of what is happening with the audience. Let's look at some of the details, starting with GSR and then adding the ECG data. GSR is the primary measure used to determine whether or not an individual is responding. Absent some stimulus that generates a response, GSR will tend to decline gradually over time. Any increase in GSR is therefore indicative of a response. For this reason, we look at the slope of the GSR curve over the last 5 seconds. By looking at a period, we automatically remove the impact of noise and other artifacts that may creep into any kind of physical measurement. If there is a positive trend over the 5-second window, that is classified at least a medium response. If the increase is more than 2% over that window, that is determined to be a high response. These thresholds, as with all thresholds in NeuroLynQ, were determined empirically, and we found them to provide very reasonable results. In addition to the slope criterion, we added another, which we call an inflection point. Anytime the actual GSR signal increases by more than 1% over the trend line in a 5-second window, we regard that as a high response. This criteria has proved very important because we find that it typically identifies the GSR responses quite quickly, usually within a second of the stimulus that generated the response. Let's look at some actual data. Below is a graph of an individual's GSR signal over time and our identification of periods of medium and high response. The green areas are areas where the slope of the GSR was positive over a trailing window, but less than 2% over that window. Red areas indicate that the slope was greater than 2%, indicating a high response. Finally, the purple areas are inflection points, where the general trend was down, but there was a turnaround. We believe these metrics capture what is actually happening. Although there is a slight lag for the high slope criteria to kick in, essentially every event was captured and the inflection point caught the move quite quickly. This graph is highly representative of literally hundreds of signals that we've reviewed when establishing these metrics. The metrics appear to do a really good job of capturing movements in GSR and identifying high and medium responses. If ECG is not collected, NeuroLynQ will use these classifications as its final result. We will now discuss how ECG fits into the picture. With our core metrics, ECG is used as a confirmatory signal. In particular, we look at heart rate variability. We estimate heart rate variability based on the range of beat-to-beat intervals. As mentioned in a previous presentation, low heart rate variability is associated with attention, and high heart rate variability is associated with orientation effects. We are interested in either effect, so both low and high variability is considered a confirmation. Moderate variability is not considered a confirmation. In the case where we are measuring both ECG and GSR, we only classify a response as high if we have both a high GSR response and a confirmatory HRV response. If there is no GSR response, we will not identify a response based on HRV alone, and the response is no response. If there is a GSR response but no HRV response, we classify it as a medium response. The details of this are documented in a white paper, which is available from our website. Let's look at some HRV data. We are showing the beat-to-beat intervals in the graph below. The red data points indicate where HRV is low. In this particular case, there were no high variability periods. Now let's put this together with the GSR data. These graphs show the data from a single person while watching 4 TV ads as marked below. The GSR and heart HRV you have seen before. The bottom graph has a purple line for a medium response and a red line for a high response. As you can see, there are a number of medium responses, but only a couple of areas of high response where both GSR and HRV lined up. It is interesting to look at a single individual, but looking at a group is even more interesting. Below are the results with 8 people looking at the same ad. The blue line indicates the percent of the audience with any response, either medium or high. The red lines indicate the percentage of the audience having a high response. 2 comments. First, from this data, you can get a strong sense of when the ads provoked a response and when they didn't. This is the main point of the metrics. Second, we use the full dynamic range for any response, and we believe the level of high responses is quite useful for analysis. Many times, people want to evaluate stimuli as a whole. We find 4 very simple metrics to be very useful for that. They are the average and maximum values of both any response and the high response metrics during the course of the window. Of course, the question immediately arises, do these metrics actually mean anything? Please look at the next presentation in our series, NeuroLynQ Validity and Reliability, to answer that question. As always, you may contact info@shimmersensing.com for more information.